All right, today's lesson is on binomial expansion. Binomial has two terms added together in parentheses, and they are raised to some sort of integer or whole number, I should say, because we don't see negative integers with this. So in this situation, we have, for example, x plus y raised to the 0, which would be 1. X plus y to the 1 would just be x plus y, or 1x plus 1y. If you FOILed x plus y all squared, you would get x plus y times x plus y. And like I said, when you FOIL it, you're going to end up with x squared plus 2x plus 2xy plus y squared. If you have a cubed binomial, this would be your expansion. This is the 4th degree expansion and the 5th degree expansion. And what you should see are patterns showing up in each row. For example, you have a 5 as your exponent here. So the exponent of x is 5 on the first term, and the exponent of y is 5 on the second term. The second term's coefficient and the second to last term's coefficient is also 5. This exponent is 1, so these exponents add to 5. These exponents add to 5. These exponents add to 5. And the exponent here on the x is 1, so these exponents add to 5. So you will see a lot of patterns in each row. What's interesting is if we go on to the next slide, you will see if you just pull out the coefficients, and again, these are the coefficients, just the number 1. This was 1x plus 1y, 1x plus 2xy plus 1y, 1x cubed would be here, plus 3x squared y, plus 3xy squared, plus 1y cubed, and so on and so forth. I think I didn't say that this was a quadratic, but that would be 1x squared plus 2xy plus 1y squared. So basically, what you're going to see when you pull out just the coefficients is that this first diagonal is all 1s, and the last diagonal is all 1s. And then take a look at this. If you add the two numbers above it, 1 plus 1 equals 2, we could keep going. 1 plus 2 equals 3, 2 plus 1 equals 3, 1 plus 3 equals 4, 3 plus 3 equals 6, 3 plus 1 equals 4, and it will keep going. 4 plus 6 equals 10, just showing a couple of examples. 4 plus 1 equals 5. This triangle is known as Pascal's triangle, and it's super helpful for finding the coefficient in the binomial expansion so that you don't have to multiply out. Like if you're in the 5th degree and you would have x plus y, that's x plus y to the 5th, you don't want to have to multiply out x plus y times x plus y times x plus y and continue that 5 times. You'd have 2 more terms of x plus y. That would take you quite some time. But if you know the coefficients of each term here, you can actually figure out the expansion a lot more easily. So that's the goal of today. The next row of Pascal's triangle, I'm going to add 1 plus 5 to get 6. First of all, I'm going to start at 1, and I'm going to end at 1, because the first term and the last term always have coefficients of 1. Then I add 1 plus 5 to get 6, 5 plus 10 to get 15, 10 plus 10 to get 20, 10 plus 5 to get 15, and 5 plus 1 to get 6. And again, that last coefficient there is a 1. So we could continue to develop the next row and the next row and the next row of Pascal's triangle. So, but what if we wanted to work with something with a larger n value, for example, x plus y to the 9th? We really don't necessarily want to build out every row of Pascal's triangle. So we just did x plus y to the 6th on the prior slide. We would have to do the 7th, then 8th, then 9th to get all the coefficients of the 9th degree expansion. But what we can do is work it out in a methodical way so that we don't have to FOIL each time, because what we definitely don't want to do is do x plus y times x plus y times x plus y 9 times. So the first term is always going to be whatever you have here. This is an x. We want x raised to the n value, the total exponent. And then we want the second term, which is y here, is going to be raised to 0 because we need the two exponents to add up to 9. So in the first term, we have 9 x's and no y's, which simplifies to x to the 9th. Then as you go into each term, you're going to decrease your x exponent by 1. So you have x to the 9th, then x to the 8th, then x to the 7th, so on and so forth for each term until you get to the last term, which will have x to the 0. And just as you went down with the x term's exponents, the first term, you're going to go up with the y term's exponents. Remember, this first term had y to the 0. Now we have y to the 1st, to the 2nd, cubed, to the 4th, all the way over here to y to the 9th. And remember, when you have x to the 0, that'll go away to 1, and your full term at the end there will be y to the 9th. So you have these patterns that you can use to expand a binomial using binomial expansion, again, without having to multiply out each binomial. So we have one more set of blanks that we need to fill in, and I'll go back here. We don't know yet what the coefficients for each term are. We need that coefficient, all of the coefficients. The only coefficient we know so far is we have a 1x to the 9th at the beginning, and we have a 1 at the end, because of Pascal's triangle has 1s at each end of the expansion. So when we have, for example, the second term is x to the 8th times y to the 1st. That means we're going to have 8 x's and 1 y all multiplied together. How many different ways can we do that? Well, let's take a look. There are 9 total exponents. Here we have y in the last position, then in the 8th, then in the 7th, and so on and so forth until we get down to the first position. If I multiply these out, every time I'm going to get x to the 8th times y all the way through. So there are 9 ways to multiply out 8 x's and a y, 9 different orders that we could put the x's and the y's in to get x to the 8th times y. That 9 becomes something that matters. What we want to do is calculate the number of x's and y's in each term. So we use what we call a combination, which in our example means we want to combine 9 terms to get 8 x's and 1 y's. This is the formula for the combination, okay? This says a combination of n total exponents, and we are going to choose r to be the y term. So in the first combination, when we're doing 8 x's and 1 y, we would have a combination of 9 total x's, 9 total exponents, and assigning just one of them to be a y. So this formula here is the formula to get the coefficient for each term. N, again, is the total number of exponents, and r is the number you're assigning to the second term, which in our case is the y term. So that's what I wrote down here. N is the total number of exponents. R is the total number of y exponents, or the exponents with the second term. This exclamation point means factorial. Well, what's a factorial? Here's an example. 5 factorial means you do 5 times 4 times 3 times 2 times 1 equals 120. So n factorial would be n times n minus 1 times n minus 2 all the way down to 1. Okay? So in our case, our n value is 9. So we would have 9 factorial divided by, and r in our case was the number of exponents to be a y. We wanted one of them to be a y. So we have 1 factorial, and then we have n minus r factorial. So 9 minus 1 factorial. I'm not going to work this out for you by hand because we're actually going to use our calculator to do this, but I just wanted to show you where the formula comes from. Now, if we took the combination 9 total exponents assigning one to be a y, this value is going to come out to 9, which exactly matches the number of ways we can multiply 8 x's and a y, the number of orders that we could multiply 8 x's and a y to get x to the 8th times y to the 1st. So 9 is going to be the coefficient of the x to the 8th y to the 1st term. But we want to do this in our calculator. So in your calculator, I want you to go, this is in your TI-84, these all should be arrows here, math, probability, and then choice 3 is NCR. This is how it's written in your calculator. You'll have to type in the n first. So in our prior example, we'd type in a 9 first, Then we would do the math probability choice 3. We would put in NCR. It would put in a C here and leave a space for the R. For the first one, we want 1 to be a Y, and we're going to get out 9. And what the calculator is doing is it's running through the formula that I just showed you, the combinations formula, which I don't need you to do by hand. If I were to do this in my calculator, combination of 9 total exponents, choosing 0 to be a Y, well, there's only one way to do that. In my calculator here, I would do 7C2, and I would get out 36. And I want you guys to go ahead and put these in your calculator and make sure you're getting out the right values. But the values you should be getting out are 84 for 9 choosing 3 to be a Y, 126 for choosing 4 to be a Y, 126 again for choosing 5 to be a Y, and then we have symmetry. We scaled up from 1 to 9 to 36 to 84, 126, 126. The symmetry of Pascal's triangle comes into play, and we have 84, 36, 9, 1. So that gives us the full expansion. We put these coefficients in here. We had a 1x to the 9th, 9x to the 8th, y to the 1st, 36th, x to the 7th, y squared, 84, x to the 6th, y cubed, 126, x to the 5th, y to the 4th, 126, x to the 4th, y to the 5th, 84, x cubed, y to the 6th, 36, x squared, y to the 7th, 9x to the 1st, y to the 8th, and 1x to the 0, y to the 9th. Okay, so let's practice one because that was a lot of information. Basically, we want to expand A minus B. My hint is that A is your first term and negative B is your second term. So in your expansion, you basically need a combination 5 choosing 0 to go with negative B. You need A to the 5th will be your first term because we have 5 exponents being assigned to A. Then to the negative B, we have 0 exponents. Then we need a combination of 5 choosing 1 to go with negative B. We need A to the 4th, and we need negative B to the 1st. And what you can see is that I'm going down an exponent value on each A. I'm going up an exponent value on each negative B. And I have the combination now 5 choosing 2 to go with the negative B. So then I have A cubed and negative B squared. Keep going. 5 choosing 3 to be a negative B. I have A squared, negative B cubed. I have a combination of 5 choosing 4 to be the negative B, A to the 1st, negative B to the 4th, plus combination of 5 choosing all 5 to be a negative B, A to the 0, negative B to the 5th. And so now I need to simplify this. Basically, I'm going to have to put all these combinations in my calculator one by one. And I'm going to get out, the first one has a coefficient of 1, and my negative B to the 0 goes to 1. So my first term is just A to the 5th. C5 choose 1 is going to be a coefficient of 5. And then I have A to the 4th times negative B. So A to the 4th times negative B. Coefficient 5 choose 2 is a 10. 10A cubed, and then I have negative B squared. Negative B squared goes to positive B squared. 5 choosing 3 goes to a 10 again. A squared, and then a negative B cubed. These negatives matter. 5 choosing 4 in my calculator, I'll get a 5 there. And I have an A, and then negative B to the 4th is just plain old B to the 4th. Then my last coefficient is always 1. A to the 0 is 1, so I have negative B to the 5th, because when I take negative B to an odd degree, I get out a negative term. And then my final answer will be A to the 5th. Make sure you pull out your negatives. So I have minus 5 A to the 4th B plus 10A cubed B squared minus 10A squared B cubed plus 5AB to the 4th minus B to the 5th. And I have successfully expanded my binomial without having to FOIL out anything. Okay, the next one is a shorter problem because they're not asking us to multiply out the entirety of the 15th degree binomial. They just want the coefficients of two terms. So there are 15 total terms, and in the first one, they're choosing 12 to be a y. So you'll have the combination of 15 total terms, choosing 12 to be a y, x cubed y to the 12th. In the second one, you're choosing 13 to be a y. So you have 15 total terms, choosing 13 to be a y, x squared y to the 13th. So this is just a calculator exercise of finding out what these coefficients are, and you'll find out that this one is 455, and this one is 105. Now, we have to worry about the sign. Here we have a negative y, so when it's raised to an even degree power, it will go positive. Here, when it's raised to an odd degree power, it will go negative. So the first one is a positive 455, and the second one is a negative 105. All right, try the next two practice problems on your own, and then come back here and check your work, and I will go ahead and work it out. I don't want you to watch it, though. I want you to go ahead and hit pause. But when you come back, here we go. We're going to have coefficient of 1, a to the 8th, b to the 0, plus coefficient of 8, or coefficient of the second term is always the total exponent. We have a to the 7th b, plus, now I need the coefficient is going to be 8 choosing 2 to be a b, a to the 6th b squared, plus the coefficient of 8 choosing 3 to be a b, a to the 5th b cubed, coefficient of 8 choosing 4 to be a b, now a to the 4th, b to the 4th, plus the coefficient will be 8 total exponents choosing 5 to be a b, a to the 3rd, b to the 5th. Clean that up, that should be the 3rd there. Okay, now I need a coefficient of 8 choosing 6 to be a b, and that is going to be a squared b to the 6th. Then I have the coefficient 8 choosing 7 to be a b, which will be a b to the 7th. Then the last term always has a coefficient of 1, and then my b term will be to the 8th. Now here, the second to last term has to have a coefficient of 8, so I didn't really need the combination there. I can just put in a term of 8. Once I put these in my calculator and I find out all of the coefficients, I get a final answer of a to the 5th plus 8 a to the 7th b plus 28 a to the 6th b squared plus 56 a to the 5th b cubed plus 70 a to the 4th b to the 4th plus 56, here's my symmetry kicking in on my coefficients. This one was 56, so this one's 56. A to the 3rd, b to the 5th. And by symmetry also, I have 28, a squared, b to the 6th, plus 8, a, b to the 7th, plus b to the 8th. And the last problem, the 5th term in the expansion. Well, the first term has a to the 10th, then it'll be to the 9th, then to the 8th, then the 7th, then to the 6th. So that's the 5th term will have a to the 6th. Therefore, b will be to the 4th because the total number of degrees needs to be 10. So I need the coefficient choosing 10 of the total exponents with 4 to be a b. And when I do that in my calculator, I get 210. So my term is 210 a to the 6th, b to the 4th.